In the lab, you guys were looking at what happened when we added energy to some matter. And basically what you saw was the more energy you added, the more those particles started to move around. And that's why we say energy is the ability to cause change or do work. When we gave those particles energy, they changed from being fairly stationary to moving a lot. And when they move a lot, they can bounce off the walls and cause things to move. So then they can cause work. They can do work. So energy is the ability to cause change or do work. You'll notice we didn't actually add any mass to those particles. We didn't make them take up more space. We just made them move a little bit more. So energy is not matter. It has no mass or volume. It doesn't take up space. It just causes things to change. Now, these types of matter you guys are probably familiar with. Kinetic energy is the energy of motion. The faster something moves, the more kinetic energy it has. The more mass something has, and it's in motion, the more kinetic energy it has. Potential energy, though, these are the ones that we kind of mess up a little bit. Potential energy is not the energy of rest. Just because kinetic energy is the energy of motion does not make potential energy the energy of rest. Rather, potential energy is the energy of instability. Instability means something is likely to change. If you balance yourself on the top of a chair on one leg, it's likely to fall over. It's likely to change. It's unstable. Okay? Now, potential energy depends on mass and position, and this is true if it's gravitational potential energy in a rock falling off a hill, or chemical potential energy, energy stored in bonds, or even thermal energy, the energy that particles have. So let's take a look at some potential energy states. So if we have a cliff, and at the top of this cliff there's a boulder, it has potential energy, but the only reason it has potential energy is because gravity can cause it to fall down to the ground here. Okay, so if it has potential energy here, by the time it gets here, the potential energy is gone. Now, that doesn't mean that energy disappeared, but what happened, it changed, and it changed into the sound that this thing made when it smashed into the ground. It changed into some heat that happened when this thing fell through the air and caused some friction to heat up the air. So it's changing into different forms, but it's no longer potential energy. It fell. It doesn't have the potential to change anymore. Now, we can apply that same thing to particles of matter. When we have a solid, all the particles have strong forces of attraction between them, and they hold those particles in place. Now, if we start heating these particles up, yes, they might start wiggling a little bit more, but eventually they actually spread themselves out. But there's still forces of attraction that want to hold those back next to each other where they used to be. So they have potential to collapse in on themselves and reform this solid. They're unstable like this. They would rather be as a solid. So they have some potential energy because of their positions relative to each other. They want to fall back together. Chemical bonds, we'll look at those in more depth later, but in chemical potential energy, you have an atom out here and an atom over here, and they really would like to get together, because if they could get together, they can make themselves more stable. And so these have high energy here, and then they form a bond, and that bond, when that bond formed, some potential energy was released, and that can create heat, that can create light. We can do a bunch of things with chemical potential energy.